Hello, listeners. Mallory Wilsey here, Chief Producer of the Enrollify Network, and I want to take just a quick moment to tell you about another show on our podcast network designed specifically for all the education technology enthusiasts out there. The Higher Ed Geek podcast is a deep dive into the world of educational technology and its transformative impact on the student experience. Geek out each week with host Dustin Ramsdell. His conversations are a mix of engaging storytelling, expert analysis, and a genuine passion for all things higher ed and tech. Whether you're an educator or an administrator or just someone passionate about the intersection of technology and education, this podcast promises to deliver content that's both enlightening and entertaining. You can subscribe to the show by visiting podcast.enrollify.org or by searching the Higher Ed Geek wherever you get your podcasts.
The advantage of machine learning is it's effectively just pattern recognition at scale. Right. So human beings have a capacity for pattern recognition. We kind of, made our name on it across the planet as we moved throughout history. But there's only so much that we can patterns that we can actually recognize, right? We also can't assign like a mathematical value to that particular pattern that we're noticing. That's where sort of machine learning comes in, is when you have huge amounts of data input fed into a model. That model can map out the patterns and also assign mathematical values to each of them.
Welcome to the EduData Podcast, a podcast that serves as your weekly guide to the data driving higher education. We are your hosts. I'm Jamie Boggs.
And I'm Timothy Davis. Join us every Friday for weekly breakdowns of the most important data, trends, and topics in higher education.
The EduData Podcast is a part of the Enrollify Network, a robust collection of podcasts designed to help higher education professionals like you grow. Explore our other shows at enrollify.org or check out some of my personal favorites linked in the show notes below.
Enrollify is made possible by Element451, the leading AI-powered, all-in-one student engagement platform, helping institutions create meaningful, personalized, and engaging interactions with students. Learn more at element451.com.
Hello and welcome to another episode of the EduData Podcast. Thank you for joining us today. My name is Timothy Davis, and I'm here joined as always by Mr. Jamie Boggs. Hey, Jamie.
Hey, Timothy. How you doing?
Doing good. We are fresh off of the Engage Summit. You'll probably hear a few episodes from us in these coming weeks that are in this sort of post-Engage Summit period. So the energy's good. The summit was great. We're just kind of riding that wave, so it's been good. But today, we kind of want to recap or at least dive into with a little bit more detail what we talked about at the Engage Summit. We had a session in the product track of the Engage Summit where we got to announce a new feature for Element451, and we want to talk a little bit about the data that we're using, the technology that's in play, and then sort of how we think about predictive analytics and in light of LLMs, or how to use them alongside LLMs. Those are all ideas that we sort of touched on in our brief presentation at the Engage Summit, but we want to take this opportunity with this podcast platform that we have to talk a little bit more about that and hopefully provide some interesting ideas for you. So with that, Jamie, could you first off start by telling us a little bit about like activity or behavior-based data that we collect at Element and how that sort of factors into our training machine learning model that we're using to make these predictions?
Yeah, so in a CRM of any type, in Element451, our partners are using our system to communicate in a variety of ways: text messages, online chat, emails, we have forms, we have surveys, we have applications, we have events, and any of those features that our partners are using, we're collecting all the data on. When was the email delivered? When was it opened? Did they click on it to go through to the link? Did they click to open it and then close it? Did it go to spam? For the SMS messages, were they clicked on in there? Did somebody go to a form, and where did they go to it from? Was it from an email? Was it from our landing page or our microsite? When they're in a conversation, how many messages are they sending? How long is it taking us to communicate with them back? How long is it taking us to respond? And all of that data is being tracked. So in putting this behavior data together for analysis, I think we started mainly just looking at, let's start with counts. How many applications let's say we make one row per prospective student. How many applications have they submitted? How many sources brought them to the website? How many emails have they opened, clicked, so forth, for every action within it? How many events have they been to? How many appointments have they scheduled? How many have they canceled? So anything that anybody could do in our system, we're going to get that aggregate count. We also want to know how often those things are happening or times between. So how long does it take somebody between their application start to their application submission? How long does it take between their initial entry into the system before they actually submit RFI form of some kind? So we have that days between metric, even to go as far as your intended term date, your intended term start date. How far back are we looking to see before your last email was opened or before your last communication happened within our Bolt Assistance, which is an upgrade to our former Bolt Bot system? So days between activity over time, I think, is super useful. And then there's just the source piece. Where did they come from? What are some other pieces to their activity puzzle, as far as did we buy their name? Did we buy their name and they came from Google? Did we buy their name and they found us on Facebook? So a lot of the acquisition, I think, is important there as well. So all that's tracked and aggregated, one row per student. We use previous data to train a model, and then we run it on records that we're trying to measure and predict.
Right. And that's, that's kind of the advantage of Element451. That's where we've been able to produce a lot of data, a lot of really valuable data, is that we've been able to capture across all those different sort of assets, whether they're events and everything else that Jamie mentioned, applications, appointments, etc. We've been able to capture all of that activity in the student lifecycle, and that's all happening natively without any additional input from Element451 users. That all just starts to get aggregated onto the contact record, and so it's very easy for us then to roll that into a predictive model. And we really like behavior and activity-based data for that purpose, because activities and behaviors are less biased than, say, demographics. Right, traditional sort of predicting about important stages within the student journey, such as enrollment, or persistence, have often just relied on demographic data, right? And as we've covered before on this podcast, right, when you're just using zip code to predict, enrollment, or you're just using household income, or you're just using race, some of these other like personal demographic data pieces, right, that can really start to skew your predictions, and you can start to unintentionally sort of predict worse results for students that don't align with your historic folks. But those behaviors even that out a little bit, right? Because most of these are like internet-based behaviors, right? All you really need is a phone or a computer and access to the internet, and that has thankfully become more and more accessible to the majority of the population, at least in the United States, and also like in Europe and other sections of the world. So very important kind of component to that. So we're excited to bring like elements, what we're calling it the secret sauce.
Secret sauce.
That's the deal. We're really doubled down on the secret sauce metaphor here for activity and behavior data. So the other one that we could talk about a little bit that might be interesting is our technology stack. Making predictions at scale has been really difficult, has been really computationally expensive, not to mention the configuration of it all. And so I'll say a little bit about this before handing it back over to you to talk about some of our initial work in Python. But basically our data ecosystem is built on Snowflake, right? We use Snowflake as our data warehouse or data platform internally, and then we also deliver analysis and then back to Element451 via a pipeline through Snowflake. So if you're not familiar with data warehouses and how like data is orchestrated in that way, that might sound like Greek to you, but basically we do all of our predictions within the Snowflake platform. Snowflake has recently released a number of like native ML features, and so we're writing defining our prediction models and training models there in Snowflake. We're using Snowflake's in-platform training, and then the compute that Snowflake furnishes for us through cloud compute providers like AWS or Azure. That compute is where those ML calculations are being run, and then we just kind of deploy those back into Element451. But basically, talk a little bit about like some of our initial work there, how we were originally writing these before Snowflake came out with these ML features, and how we were taking cracks at deploying predictions at scale.
Yeah, so we started out just trying to write this ourselves. There are so many different analytical models out there that I've worked with in the past. There are so many decision trees, random forests, random trees. There are a lot of boost models, which I really like. There's some neural network models, and I really focused the Python early on those boost. I was using some XG boost models and some neural network. And neural network is super, super in depth. It takes a lot of computation to put that all together. Basically, it looks at every possible combination between the factors, and it's super accurate. It's a great model, but it takes a long time and a lot of costs at using that. So we use the scikit-learn library to bring in the boost models, and then we would work, and we worked for months on trying to perfect this, on getting the data in, organizing it properly within the Python script, and then getting it to loop by client and that kind of thing. So worked for a long time on getting that right, getting it to where it was accurate but not overfitting is always a big balance. And that's why I like boost models as well, because you can tinker with the parameters to kind of find that balance. So we were moving toward actually putting our Python into action when Snowflake popped up, and I'm going to make this joke, nobody may get it. It Kelly Clarksoned me. It came along and did what I was doing, but did it a lot better. Like when she covers people, she just ruins them, right? And that's what Snowflake did to me. Not only was it better than what I was doing, but it was exactly what we were working on in Python. It's a gradient boosting model which essentially that's taking a lot of decision tree models and using them to build off one another and get better. And that's the type of model that it's using. So now instead of writing a whole Python script that runs through our automatic DBT procedures through Snowflake, we essentially just build the table, tell Snowflake what to do, and Snowflake runs the same model we were going to run anyway. And then we start to put together the results to display on our platform. Was that too nerdy? I thought the pop culture reference might alleviate the nerdiness. I don't know.
Absolutely. I think Kelly Clarkson is really going to get us through.
Yeah, I know she listens. She's a big fan.
Absolutely. Yeah, for sure. Well, like to kind of break that down just a little bit further, like to do ML or machine learning predictions about, whether or not the percentage chance a given student will complete X, Y, or Z action, you need three things, right? You need the data, which we kind of talked about originally. You need to define what that data is and does, right? And kind of configure the model that you're going to use. And then you need a lot of compute power. So we had always sort of been built on Snowflake for the compute power. Snowflake has been our data platform for a while. And of course, we would just kind of bring our data to that. And then Jamie's work that he was just sort of defining was that middle section there. Like, how do we configure the model? How do we give this data meaning? How do we define our target, which in our case was actually multiple. We're actually doing multiple predictions at this point against enrollment, against applications, against prospect or date of inquiry. So we're doing a number of predictions, defining that target in the code. Basically, Snowflake, as Jamie was saying, like came along and sort of abstracted some of that away. So all we really had to do was bring our data set to this Snowflake configuration, and then Snowflake defines sort of the rest for us. So that's been really helpful and helped us deploy this a lot faster without needing to worry about as much configuration.
Yeah, and it's been very not only helpful to take away some of the typo errors in writing your own code, but in just the ability to retrieve all of the data that we want, because we want to look at feature importance as well. Not only what are we predicting for their likelihood to persist or enroll or whatever, but what's contributing to that. We're able to see that, wow, people who take a long time to complete their application really usually end up not enrolling, and that's not an outcome we've seen. That's just an example. Or Somebody who just doesn't ever click on links in emails, they're not coming. So we need to know that. So those are things that are standing out to me as just really, Snowflake makes it easy to pull out that feature importance, to pull out the evaluation metrics, to find out your accuracy scores and confidence intervals and other nerdy things.
Absolutely. Well, the advantage of, to speak a little bit about machine learning, the advantage of machine learning is it's effectively just pattern recognition at scale. Right. So human beings have a capacity for pattern recognition. We kind of, made our name on it across the planet as we moved throughout history. But there's only so much that we can actually, patterns that we can actually recognize, right? We also can't assign like a mathematical value to that particular pattern that we're noticing. That's where sort of machine learning comes in, is when you have huge amounts of data input fed into a model. That model can map out the patterns and also assign mathematical values to each of them. That usually comes in the form of percentages, and that's what Jamie was talking about with these feature importances. We can say this particular input variable, whether that's time between application start and submit, or maybe that's whatever else that we're feeding, we can say that this has this percentage of importance at predicting this outcome. So that's of course very interesting. LLMs like ChatGPT or like Element's AI assistants, Bolt AI assistants, are similarly doing something else, just with language. They're making language predictions, and those language predictions are based off of lots and lots of training inputs across lots of language data, written, spoken, voice, whatever they can sort of get that model trained on. And that kind of creates some general knowledge within that LLM that it can sort of speak to. And that's why when you prompt ChatGPT for, give me 5, recommendations for what I could do to, improve my health or whatever, it can give you like decent sounding recommendations, right? Well, Element's Bolt AI assistants can do the same thing, but with the context of Element data. So right now in Element, you can use our staff assistants to ask questions about contact records. So if you've got a student contact record in Element, you can pull that up, and then in a dialogue with one of our Bolt AI assistants, you can ask like, what's going on with the student? What's the last thing they did? Or what's the next thing I could do to nudge them along? Right. And so the LLM is not making up information about that student at that point. We actually give the contact records information to the LLM at that point to generate its response. So it's giving you accurate information about that student. But when it comes to making prescriptions, recommendations about what to do, the LLM is still at this point using its general knowledge. So if you ask, what should I do to nudge a student along to start their application, or what should I do to keep the student engaged after they've been admitted so they actually enroll, right? The LLM is using its general knowledge about the admissions process based on data it's been trained on to write out those predictions in plain text, right? But it's not actually using the context of all of your Element data, given that you're an Element451 user, right? So what we're kind of doing here with this initial priority index, and what we'll be doing in future projects, is using aggregate levels or even contact level predictions about all of our partners' data within Element451 to inform those LLM responses. So basically, instead of saying you could do X, Y, and Z based on, my general knowledge, my assumptions about what should be done, the LLM can say, here is what has been successful at your institution. Here is what we've measured to have moved the needle, right? So the LLM having the full context of your institution, both from like an informational, knowledge-based perspective, and also from the insights and analysis that we can surface through all of the Element451 data that we collect about activities, about contacts, about how the institution operates. We can feed all of that to the LLM to create highly informed contextual responses. So did you want to add anything about that, Jamie? Or?
Yeah, I liken it to the difference between just going to the doctor and saying, I have a fever, and the doctor giving a prescription or tell you what to do, versus them having all of your symptoms, all of your blood work to make a more informed recommendation for how to get rid of the fever. We're here with the blood work to help you get your students across that goal line and enroll without a fever. Mixed metaphors.
Absolutely. Yeah. So just providing much more much more heightened context
Right.
for that response. A perfect analogy there. That is the first time hearing this analogy, and I love that.
I've been watching a lot of House lately, and it's kind of like Sherlock Holmes as a doctor. So like a lot of a lot of diagnosis, and I feel like that's what we're doing. We're diagnosing where these students are and how to get them across the finish line.
So many whiteboards.
So many.
Yeah, and a cane.
And I don't use it, but I have a cane just in case, because House is great.
Yeah, just in case you need to kind of do a house bit to really enforce the concept.
Right. Which I will be doing next year at Summit. So if you haven't gone to the Engage Summit
Absolutely.
and you want to see me present with a cane, I'll be there.
Perfect. Well, hey, thank you again for joining us, everybody, and I hope this was interesting for you to hear how we sort of think about predictions and how to inform LLM responses. For Jamie Boggs, I'm Timothy Davis. We'll see you in the next episode.
The EduData podcast is part of the Enrollify podcast network. If you like this podcast, chances are you'll like the other Enrollify shows too. Our podcast network is growing by the month. We've got a plethora of marketing, enrollment, and higher ed technology shows that are jam-packed with stories, ideas, and frameworks, all designed to empower you to be a better higher ed professional.
Our shows help higher ed marketers and admissions professionals find their next big idea and feature a selection of the industry's best as your hosts. Learn from Jamie Hunt, Artis Cadu, Dustin Ramsdale, Jeremy Tiers, and so many of your other favorite leaders in higher ed. Enrollify is made possible by Element451, the leading AI-powered all-in-one student engagement platform helping institutions create meaningful, personalized, and engaging interactions with students. Learn more at Element451.com.